Hello, sci-fi enthusiasts and curious minds. I'm Liana, your guide for today's expedition into the realm of time travel. The very term time travel invokes a sense of mystery and excitement, doesn't it? This fascinating concept has held us in its grip for centuries, sparking endless debates and discussions. It's a topic that has been thoroughly explored in countless movies, books, and TV shows, from classics like H.G. Wells' The Time Machine to modern marvels like Doctor Who. The idea that we could journey into the past or future, to witness events or meet people beyond our time, is incredibly tantalizing. Could we change the past? Could we foresee the future? These are questions that have piqued our collective curiosity and fueled our imagination. Time travel, while currently beyond our reach, continues to enthrall us with its endless possibilities. So buckle up as we delve into the exciting theories of time travel. Our first stop on this journey is the wormhole theory. Now let's imagine you're trying to get from one point in space-time to another. You could take the long way around, or you could take a shortcut. This is where the wormhole theory comes into play. A wormhole, in essence, is like a tunnel with two ends, each at separate points in space-time. Picture it like a cosmic shortcut, a bridge, if you will, that links two different points in space-time. It's like folding a piece of paper in half and pushing a pen through the fold to get from one side to the other, bypassing the space in between. Now, you might be wondering, what does this have to do with time travel? Well, think of this. If these 2 points in space-time are not just different locations but different times, then voila, you have a time machine. In other words, if one end of the wormhole is anchored in the present and the other in the past or future, then theoretically, you could step into the wormhole and emerge in a different time. But here's the catch. Wormholes are purely theoretical at this point. While Einstein's theory of general relativity allows for their existence, we've yet to find empirical evidence of them. And even if we did find one, it's uncertain whether it would be stable enough for us to travel through. According to some scientists, a wormhole could collapse upon itself the moment anything tries to pass through. Furthermore, there's the issue of size. Most theories suggest that wormholes, if they exist, would be microscopic, making human travel through them a bit of a squeeze. Not to mention, the energy required to keep a wormhole open would be immense, possibly even requiring forms of matter and energy that are purely theoretical themselves. So, in theory, if you could find a wormhole, you might just be able to travel through time. Sounds like a sci-fi movie, doesn't it? Next, we move to a theory that involves something we encounter every day: light. Imagine if you could travel faster than the speed of light. Sounds like pure science fiction, right? But some theories suggest that exceeding this cosmic speed limit could potentially lead to time travel. To understand this, we need to delve into Einstein's theory of relativity, a cornerstone of modern physics. In the early 20th century, Albert Einstein proposed that space and time are interwoven into a four-dimensional fabric called space-time. He suggested that massive objects, like planets and stars, cause this space-time fabric to curve, creating what we perceive as gravity. Now, here's where things get interesting. Einstein also postulated that nothing can travel faster than light, which zips along at a staggering speed of approximately 186,000 miles per second. So, what happens if we could somehow break this cosmic speed limit? According to Einstein's equations, as an object approaches the speed of light, time for that object slows down relative to the rest of the universe. This is known as time dilation. So, if you were able to travel faster than light, in theory, you would be moving backward in time relative to the rest of the universe. However, there's a small catch. To accelerate an object to light speed would require an infinite amount of energy, which is, to our current understanding, impossible. Not to mention, it would also cause the object to have an infinite mass. But don't let these technicalities dampen your spirit. Theoretical physics is a field that's constantly evolving, and who knows? One day we might discover a loophole in the laws of physics that allows for faster-than-light travel. So, if you can figure out a way to travel faster than light, you might just be able to visit your future self. Now, let's venture into the realm of cosmic strings. Cosmic strings? No, not the kind you'd find on a celestial guitar, but hypothetical, one-dimensional topological defects in space. Picture, if you will, incredibly thin, incredibly long strings stretching across the universe. They're so thin, in fact, that they're almost one-dimensional, but their length, that could span the entire observable universe. These strings are formed during phase transitions in the early universe, according to the theory. They're a bit like the cracks that form in ice when water freezes, except these cracks or strings are in the fabric of the universe itself. Now here's where things get interesting. These cosmic strings, if they exist, could potentially warp space-time around them. And when two of these cosmic strings pass by each other at just the right speed and angle, a loop could form. This loop theoretically could create a closed time-like curve. In layman's terms, this could allow for time travel. You see, if you were to move around this loop, you could end up at a different point in time. The potential for time travel via cosmic strings lies within these loops and the warping of space-time. However, before you get too excited, it's important to note that this is all purely theoretical at this point. Cosmic strings, while a fascinating concept, have not been observed, and their existence remains a topic of debate among scientists. Even if they do exist, harnessing their power for time travel would be another monumental task. We would need to understand them far better than we do now, and develop technology far beyond our current capabilities. While this theory is a bit more out there, it's still a fascinating concept to ponder. After all, who knows what secrets the universe holds? After all these theories, you might be wondering, is time travel fact or fiction? Well, time travel is a tantalizing concept that has held our collective fascination for centuries. Who wouldn't want to journey to the past to witness history firsthand, or to the future to glimpse what's yet to come? The possibilities are endless and intriguing. But let's put our feet back on the ground for a moment. What does science say about it? As of now, the scientific consensus is that we don't have concrete evidence to support the possibility of time travel. The theories we've discussed, such as wormholes, speed of light travel, and cosmic strings, still remain largely theoretical. They are based on mathematical models and predictions derived from Einstein's theory of relativity, but we have yet to gather empirical evidence to validate them. Furthermore, even if these theories prove to be true, they present significant challenges. For instance, the energy requirements to create a wormhole or to propel a spacecraft to the speed of light are phenomenally high. Not to mention the potential paradoxes that could arise if we could change the past. However, this doesn't mean that time travel is entirely off the table. As we delve deeper into the mysteries of the universe, our understanding of the nature of time and space continues to evolve. Who knows what discoveries the future may hold? In the meantime, time travel remains a cherished staple of popular culture. It allows us to explore the human condition from unique perspectives, to ponder what-if scenarios, and to dream of a future where the constraints of time no longer bind us. So, while we might not be hopping in a time machine anytime soon, the theories and concepts we've explored today continue to captivate scientists and sci-fi enthusiasts alike. Our journey through time, it seems, is far from over. Well, that's a wrap on our journey through the theories of time travel. We've delved into the mysteries of wormholes, pondered the implications of light speed, and tangled with the complexities of cosmic strings. Each theory, in its own unique way, has expanded our understanding of time and space, challenging our perceptions and fueling our imagination. While time travel remains a topic that straddles the line between science and fiction, the allure of its possibility continues to captivate us. We've seen its influence pervade our popular culture, its concepts intricately woven into the narratives of our favorite movies, books, and TV shows. It's a testament to our collective curiosity, our relentless pursuit of the unknown. If you enjoyed this video, don't forget to hit that like button, share it with your fellow sci-fi enthusiasts, and subscribe to our channel for more fascinating journeys into the realm of science and technology. This is Liana signing off. Until next time, keep exploring.